everyone, welcome to the Math Tablet. In this session we're having a look at differentiation, in particular optimization. Now in optimization, essentially what you want to do is to find the maximum or the minimum of something. So here's a classic example. We have a closed rectangular box with square ends which has a total surface area of 600 square centimeters. What is the largest volume it can contain? So our first step is to decide what is our objective function. So our objective is the thing that we're trying to find the maximum or the minimum of. So here we're after the maximum volume. So we're trying to maximize the volume of this box. A diagram will often help. Okay, so here is my box. Okay. It's got square ends, so let's call that x and x, and the height of that box h. Okay, so the volume of this box is going to be x times h, which is x squared h, isn't it? Okay. Now, normally when we're trying to find the maximum or minimum of something using calculus, what we would do is to differentiate it and set it equal to 0 to find the stationary point, because whether it be a minimum or a maximum turning point, the stationary point would have to have a gradient of 0. Now at this stage we can't differentiate this volume function yet because we've actually got two variables here, x and h. Okay, so we need to get around that by using our constraint, which is usually the other piece of information you're told within the question. So notice here that we've actually got information regarding the surface area. Now the surface area we're told has to be restricted to 600 square centimeters. So the surface area of this box, let's see, the top and the bottom, you're talking about x squared and x squared, so that's going to be 2x squared. And then the side panels, well, one side panel will be h times x, isn't it? So now I've got 4 of those, so let's go 4xh. That expression there is the expression of the surface area, so that has to equal 600. Now what I'm going to do here is to rearrange this so that I get h in terms of x. Okay, so 4xh equals 600 minus 2x squared, which means that h must be equal to 150 over x, take x over 2. Now that I've got h as the subject of the equation, what I can do is to substitute it in here so that the volume will be all in terms of one variable. So if I just substitute that, I would have x squared outside of 150 over x minus x over 2. So now this objective function, this volume function that I'm trying to find the maximum of, is all in terms of one variable, and that is x. So I can actually differentiate and set it equal to 0 to find the maximum turning point. Now often a question like this would appear in resource switch, which means that calculators are certainly allowed. So let's pull up our class pad and let's find the derivative of this. So d by dx of, let's see, x squared times 150 over x minus x over 2, and that gives me my derivative. Okay, so v dash is negative 0.5 outside of 3x squared minus 300. And just to confirm that I've used my calculator here, my class pad, to find out, I can put g/c there just to show you that that's how I've obtained my answer. Okay, so now I need to set this derivative to be equal to 0 in order to find the stationary point. So let's go 0 equals all of this. So edit, copy, in here, edit, paste, and I want all of that solved. So interactive, advanced, and solve. Okay, so I end up with two answers, x equals negative 10 or x equals 10. Okay, so let's just put that down in here. So what have we done? We've set the derivative to be equal to 0. And that gave us x equals -10, which is obviously going to be an answer we reject. It doesn't make sense to have a negative value for x there. Or x equals 10. Now, if x equals 10, let's just find out what h would be. So we would go 150 over 10 minus 10 over 2. So h would work out to be 10 as well. So I'm almost there. What I need to do is to double check really that it is indeed a maximum. Okay, so check that stationary point is a maximum. Okay, so set up your sign test. Okay, so v dash x equals 10. So let's say we choose x equals 11 on that side and x equals 9 on that side. We know the gradient to be 0 at x equals 10. So bring up the class pad again. Okay. So really what I want is that that evaluated. So option vertical line x equals 9, that comes to 28.5, so this is 28.5, and then x is 11, so paste again, and x equals 11, negative 31.5, so negative 31.5. Remember, the value doesn't matter here. The fact is this is a positive gradient, 0 gradient, negative gradient, which would imply a maximum turning point. So we know that the point we found is indeed going to give us the maximum volume. So now we answer the question. Therefore, maximum volume is achieved when the dimensions are 10 centimeters by 10 centimeters by 10 centimeters, which gives it a cube, isn't it? i.e. the maximum volume is 1000 cubic centimeters. So there we have an example of optimization. I hope you have enjoyed the session of the math.